Welcome back. This is Defender Chassis. My name's Scott, and today's project is the beginning of a multi-part series on building a louver punch. This is a project that I've been collecting material for quite some time, but now I believe I've got everything that I need to get this thing together, and it's time to get it done. Now, the inspiration for this project comes from one that somebody else did out on the West Coast, a gentleman by the name of KiwiKev on a message board that I frequent, and I'll put you a link in the video description. But so you don't have to do that to see what his project looks like, let me go ahead and give you a little video slideshow of what he did and what his finished project looks like. So that's it. That's what inspired me to start this project. I'm going to do things a little bit differently. KiwiKev fabricated all of his tooling, all of his drive unit. But what I'm going to use instead is this Mittler Brothers setup. Now, this is a pretty pricey unit. I would have never done this project if I had to have bought this for full price. But the story behind this is there's a guy out on the West Coast, and I forget his name. He's got a website, and if I can find it, I'll put a link in the video description. And he restores Porsches. He bought this setup with one project in mind, thinking that he may use it in the future. He did not, and after a period of time decided it was time to get it out of the shop. So he sold it to me, and we negotiated the price. It was a little over half of what this stuff would have cost new. So he shipped it all out to me, and I paid him for it, and that's really where this project started. Now, Mittler Brothers, and I'll put a link in the video description to where you can take a look at this stuff and the links for the details on how to use it. They've also got a design, a drawing for a frame to mount this stuff to. And unfortunately, it's just absolutely huge. It's 4-inch tubing. It's very cumbersome. I'm sure it's very stiff, but I don't think that you need, after seeing what KiwiKev did and how his functions, I don't think we need a frame that big. So what I'm going to do is something very similar to what KiwiKev did. His frame was an Oliver jigsaw, and I've sourced an old piece of equipment, and we're going to use that frame from it to create my louver punch. So let me move the camera, and we'll take a look at the frame, and I'll tell you what it is and how I got it and all that. So hold tight, I'll be right back. What we have here is a Crescent bandsaw frame. I bought this saw complete in a state of disrepair from an equipment dealer in Cleveland, Ohio. The name of that company is HGR Industrial Sales. I'll put a link to them if you're close. I'm 3 hours away, and I've bought several pieces of equipment from them. It's not a big deal to go up there. It's a day trip, and you can see pictures of the stuff online. Go up and take a look at it. If you want it, make a deal on it, get it back. So that's what I did with this. They had this saw for a very long time. They were asking a lot of money for it, but it had some broken pieces. This assembly for the tilt feature on the primary table was broken, and so that really made it prohibitive to try and fix this thing. So the price went down, down, and down until finally I went ahead and pulled the trigger and went up and picked this thing up. Now, it had a absolutely huge 3-phase motor. What was odd about this bandsaw compared to a lot of others from this same era is that the motor drove the lower wheel in direct drive, rather than having the motor set to the back and then having a reduction pulley assembly on the side. So the lower wheel actually mounted to the shaft of the motor, and the lower wheel was cast iron. Now, oddly enough, the upper wheel was aluminum, and I really don't have any idea why they did that. Maybe one of you guys have got some insight into that. But I kept the wheels. I kept the primary and the secondary table in the thoughts that I may use them in like a furniture project or something later. But I took the rest of it, including the motor and the guard assembly and the tension assembly, everything, and scrapped it, and came very close to getting all my money back out of this saw. The motor alone accounted for probably 90% of what I got back because of the copper. And it was just, I forget what that motor weighed, but I mean, two guys couldn't pick it up. I'm not 100% sure how old this saw is. I know that before I tore it down, there was a maintenance tag on it from Corning Glass Works from 1941. So it's at least a 1941. So after I got it all torn down, scrapped everything that I could, got my money back, I took the saw, the frame, and had it all sandblasted, got all the paint off of it, and then brought it back and put a coat of primer on it to keep it from rusting. And that's where we sit today. So the next stage of this project is going to be a way to mount the lower die. So what we're going to do is we're going to cut this off so that we have a flat place here to work from, and then we're going to create an assembly, and I'll show you that here in just a few minutes. We're going to create an assembly that will allow that lower die to be mounted and be adjusted so that it can be set up correctly. Part 2 of the project will be mounting the head, and I think we'll do that very similarly to the way KiwiKev did his. We'll have some plate steel cut, either water jet cut or plasma cut, something of that nature, so that we can bolt that whole assembly to the side of this upper arm. And then, you know, parts 4, 5, and on for this will just be, you know, tying up the loose ends. And we may make this a continuous project. You know, we may end up doing part 12 someday, where, you know, where it's rather than the construction of the front of the equipment, it'll be, you know, what's the next thing we use it for. You know, if we punch some louvers in the hood of a 65 Buick or whatever, we'll just extend the video series that way and keep it going. So let's go take a look at what I've got going for this lower die assembly. So here's the blade that I got to use to cut that cast iron. It's 9-inch Diablo Steel Demon, 8 threads or 8 teeth per inch for 3/16 to 1/2 inch thick metal, cast iron, high strength alloys, and stainless steel, carbide tipped. So we'll give this a try on the old Sawzall. I've got a great big old nasty DeWalt Sawzall that's really too big. I wish I'd have bought the smaller one, but I'm sure it'll handle cutting this thing without a problem. So we'll see how that works in part 2. Now, that lower die mount, what I'd like to do differently than what KiwiKev did is, after we cut that assembly off, that head that tilt table mounts to, what I'd like to do is cut that all flat and dress that as necessary to get that flat, and then cut a piece of steel 3/8, 1/2 inch thick, something of that nature, to sit directly on top of that, and then put some brackets on the side to hold it in place. And then directly on top of that, I'd like to mount this tubing assembly. Now, all this is a piece of 4-inch diameter, 1/2 inch wall tube that I took to a local machinist and had him cut a taper. Now, I forget what this angle is. This matches the taper on this lathe faceplate. This is an L1 taper, and you can find the specs of that online. And what the idea is that where that tilt assembly now exists, this tube will then set, and we'll get this thing on there perfectly plumb, and then this lathe faceplate will set directly on top of that. So that's there. Then this will set directly on top. And now instead of being a lathe faceplate, this will be like a work table on a drill press or something of that nature. And we'll be able to use these slots to clamp down whatever lower die assembly that we've got. So like this lower die will be here somewhere, and we'll clamp that and hold it in the correct position for that cutting edge. One of the things I need a little bit of help with, when I had that taper cut, I considered having a keyway cut because this faceplate has a keyway in it to keep it from spinning. Now, of course, originally this was designed, to handle a torsional load. As whatever you've got mounted to here, you're going to be cutting and applying that torsional load. So that key is going to, obviously see some load. Now, the way we're going to use it, we're only going to be applying a force in this direction, and really nothing should let that thing move. And its weight alone really does a pretty good job of keeping it from spinning. But if something were to happen and this thing were to get bumped or something, then this die would actually spin, and we could maybe have a condition where we end up damaging the tooling because we weren't aware that it got out of calibration. The obvious answer is to install that keyway and then set that directly down on top of that keyway. But the guy that machined the taper for me said he had an idea, and it's much more permanent installation. And maybe we don't need anything differently. But what he said was to, when everything's said and done, you're going to put this on for the last time, to put some green Loctite around this surface of this taper, and then install the table, and then it's never gonna come apart. Now, I'm not sure. I'm sure with like a sleeve or a bushing or something of that nature that Loctite works very well. I'm not sure what it would do on this taper, but this setup with this angle, is actually meant to be drawn together. You can see here on this faceplate that there are threads. If you watch Keith Finner's channel, the Turn Right Machine Works, his lathe has a very similar attachment for the chucks, and when he puts a chuck on, he's got a great big old wrench that tightens this thing down. So there's no need to reproduce that here, as all the force will be coming from one direction, but there does need to be something, I believe, to keep this thing from spinning. So let me know what you think, whether you'd go ahead and cut the keyway or do the Loctite. Of course, obviously, if you do the Loctite, then if this thing's painted, you're going to have to apply some heat to it to get it back apart someday. But then again, not sure why you'd ever take the doggone thing back apart. So anyway, listen, give me a comment, let me know what you do. If you like the project, go ahead and give it a thumbs up, and subscribe so you know when the next part of this thing comes out. Thanks for watching. I'll see you on part 2.